Okay. Let's see. It says we're live. I can't tell. Yeah.
You have a feedback loop.
Yeah, I have a feedback loop. Okay, now. Cool. Okay. All right, everybody's rolling. Hanlon is here. Choco. Ricardo. What's up, Ricardo? Let's see. Matt's here. Matthew. Hi, everybody. We're just getting started here. This is going to be a really interesting session because me and Mikhail were just kind of hacking around, and I was testing Kaping, and I think I wound up finding a tiny little bug involving egress, so we might just hack live on it. Big thanks to Mikhail for joining the stream, and Ricardo, I also added you on the stream, and I sent you a link if you want to join the actual stream. You're welcome to. But either way, so I guess we'll get started. So welcome, everybody. This is it's the April the 30th. It's my second TGIK to do, and my name's Jay, and we have a special guest today, Mikhail. He's the creator of Kaping. He he's also my friend, and he lives in France, I think, and
Yes.
he thinks he has a solution to the Coop Proxy problem, and so we're gonna walk through some of that today, and we're gonna look at the sort of the general problems with Coop Proxy that have sort of led us to the point of like sort of thinking about like what we can do to make it easier and to understand what's going on and stuff. And so that's kind of it. I don't have much for the weekend review, but there's a few things that I was looking at that I thought were kind of interesting. So yeah, let's get started. So Antria is now a part of the not a part of the CNCF, but it's incubating. So if you look over here on my screen on the right here, you'll see we have it's now incubating as a sandbox project in the CNCF. So some of the Antria team, Antonin and Abhishek and Junjen and everybody else, have been working really hard on that. So that's really cool. That's like one thing that's going on. And let's see, what else have we got here? Submariner. Okay. So Submariner Antria is a CNI provider, for those of you that don't know. We tend to test a lot with Antria and Calico over here, and sometimes with Cilium for development, at least when I do demos. And Submariner is like a federation, like a data plane federation tool. Does anybody know much about Submariner? Like, I don't know, maybe Pear knows about it. He just joined. I've never used it, but evidently it solves this whole problem of I've got two different clusters and I want the pods to talk to each other over some kind of like overlay or whatever you call it. And so, yeah, that's all the news. 1 second while here we go. Okay, and let's see what else we've got. Okay, Ingress. So another announcement for this week is we have a blog post that came out recently, and it's about the whole gateway API stuff. So I don't know if any of y'all are following the gate. Oh, so what problem does it solve? Hi, Suresh. So Submariner, I think putatively, I guess, is supposed to solve the problem of I've got two clusters and I've got like, the pods on the individual separate clusters. I want those pods to be able to talk to each other. It's just cluster federation, right? And so it's in the CNC, I guess it's in the sandbox now. So that's kind of the big update there, but I've never used it. So if anybody in the chat wants to, Yeah, that's the idea, Jay. So the next thing is this. There's a blog post that came out. I'll open this up. It's here about the Gateway API. So how many of y'all know about the Gateway API? Hi, Evan. Hi, Ajay. Hi, Per. Hi, Suresh. Hi, Dennis from Germany. Irby from London. What's up? What's up, Matt? Oh, okay. Oh, yeah, I'll send it to you, Ricardo. The evolving. It should be in your chat history, Ricardo. Actually, evolving the network. Networking this post from the API Gateway group, the SIG network, sort of L7 subproject, right? The idea, the Gateway API, what it does is it kind of evolves ingress. So I'm sure you all know about ingress resources. I'm going to pull up the ingress stuff on the side, and so this gateway stuff is gathering a lot of momentum, and so this blog post really kind of describes why it's valuable and stuff. So I'm going to, on the side over here, pull up the ingress API. So we've all kind of known about the ingress API for a while, and I'm sure most of us have at least thought about using it or used it. It allows you to sort of give you an L7 load balancer to the inside of your cluster through a cluster IP service, right? So anybody that's hosting an application in production knows about this. Ricardo knows a lot about it. I think he was working late on it last night. Anybody using the Nginx ingress obviously has dealt with this, but it wasn't really built for, like, it was kind of built quickly. It wasn't really built for multi-tenancy. It has like some issues around that. So sort of this group in the SIG network was kind of working on this idea of how to make it more modular and make it work for multiple people, so that developers could use a set of API constructs and administrators could use another set of API constructs to manage the way that gateways and ingress into your cluster works. So all that sort of conceptualization sort of resulted in this new API called the Gateway API, which is kind of like I don't know if I'm allowed to say this. I guess it's a replacement for ingress, but maybe it's not. But it's maybe the evolution of ingress. So there's a really good post on it. It's here on the CNCF, the Kubernetes blog, 2020. And it talks about how administrators use things one way and users can modify these other API objects, the HTTP route and the service objects, right? So ingress is moving forward. And I think a lot of this evolved from the early work that like the Contour folks were doing. They actually linked to a real good presentation in here that describes why they needed to build this and how there was all this fractionation in the ingress ecosystem and how it was just getting really messy. So actually associated with that, actually there is a new little subproject type group that Ricardo has started called the to help maintain the sort of legacy-ish sort of Nginx gateway ingress controller. So if anybody wants to get involved with that, reach out to Ricardo Katz in the upstream K8 Slack. Yeah. So there's that. What else do we have? We have another post that we came out with about network policy conformance that sort of talks about where we're at, the network policy subproject. So by the way, this week in review is a little thin. It's mostly focused on some network related issues, but if anybody has anything else they want to announce, I'm happy to talk about it. So we kind of started the network policy subproject a long time ago, and it was originally just because we wanted to make it easier to understand how to evaluate network policies. So we built these matrix, these table tests to give you like sort of a truth matrix. And then recently, Matt, who's here, wrote Cyclonus, which allows you to not only test, we test 40 or 50 or 30 or 40 policies or something like that in upstream K8s. And we can validate any CNI provider and whether they support those various policy scenarios and all the different connectivity that you may or may not want once you apply a policy. But Matt went ahead and sort of one-upped us and built something that actually tests hundreds of policies, and it automatically generates them, and then it tags the policies by their various attributes. So if you're confused about your CNI provider, whether it's the right solution for you, whether it supports all the network policies you care about, you can use this Cyclonus to validate all sorts of different policies. So we talked about that, and we also talked about a few of the improvements we've made to the NetPol API. We now have a default label in all K8s namespaces. So if you fire up a 1.20 cluster, you'll get this, Kubernetes.io metadata.name. And so in any namespace, which means you can make network policies against any namespace, whether or not you have the ability to label it, which was something a lot of folks had been asking for. There's also a fully qualified prototype of a FQDN network policy controller that came out from the folks at Google. That's pretty cool. So if you go here, it's real easy to run. They've published the images. You literally just have to where is it? It's just like one or two. It's like in the examples, I think. Let's see. Where do you install it? Annotations, limitations, use cases. Yeah, here it is. All you got to do is apply this cert manager and then apply this controller, and then it'll start a controller on your cluster, and then you can make policies against the L7 network policy, and it'll go and it'll, inspect the downstream IPs from that and create network policies on your cluster for it. So that's kind of a cool update. And then we have port ranges. So Ricardo worked real hard to implement port ranges. So now you have network policies that support port ranges. We have implemented that in at least a few of the CNIs. We've done it in Antrea for sure. I think we've done it in Calico, and I don't know if we did it in Cilium. Ricardo would know. I see you here, Ricardo. I'll turn your stream on. Oh, here you are. Yeah. Hi, Ricardo. So
hey, what's up, folks?
Yeah, so we implemented that. We implemented those port ranges in Antrea and Calico, and I don't know if we implemented them in Cilium yet. You might know, Ricardo.
Yeah, Cilium they are moving forward. There are some technical issues with the BPF.
Okay.
But they are doing that, yeah.
Cool. So yeah, port ranges, at least in some of the CNI providers, we have them, which makes it a lot easier to write your policies. So as an example of how you might be able to, we don't have a port range in here, I guess. We we didn't do a very good job on this blog post. We left the port ranges out, didn't we? But yeah. So anyways, port ranges look something like, let me pull up down here. Port range or port ranges and services. Oh no, that's different. Port range network policy. Port range network policy. Yeah. Yeah, here we go. Here it is. Yeah, here it is. Cool. There it is. And wow, 27. Oh, this is because it's all the API changes. Yeah. So here's the change. Yeah, here it is. So we now have an end port, right? So when you used to be, you could only define a port for network policy to target. So all your policy would only target that specific port if you mentioned it. But now you can actually have an endpoint too. So your whole policy range is affecting the whole range of ports. So that is another change that came about. So we have this post here that we'd love for you all to read about. And so, yeah, so there's a couple of different sort of SIG network groups there that represented the gateway folks and the network policy folks. And I think that's all the news I got for you. And I'm just going to sort of dive into stuff. And I think we found a bug, so we might just start hacking immediately. What's up, Vlad? I just saw you joined. And well, Vlad's here. Vlad, what can you post the link to your test framework that you've been hacking on so I can show some folks? Because Vlad is working on making it easier to write upstream tests in K8s. And I thought I had that link somewhere, but I haven't posted it in here yet. So once you post it, just let me know. I'll take a look at it. I'll show some folks. Just interrupt me. There is yeah. So okay. So all right. So why Coop Proxy? Does anybody here want to take sort of like a guess at or want to suggest? Has anybody here have any experiences with Coop Proxy? Any negative experiences or positive experiences with it? Have you ever tried to scale it at 100, 200 nodes? Have you hit anything? Oh, cool. You added the endport test to Cyclonus. Good. Okay, good. So we have another test case in there. Yeah, I think anybody who's run like large clusters has hit this. So like, back in the day, we used to try to test things at sort of like large clusters, 1,000 node clusters and 10,000 node clusters. And you often can hit issues where you have these watches, and the watches, this was written up, these folks, the OpenEye.com, they actually wrote a good post about this. Let's see. Yeah. So they wrote a good post about it. And if you look in here, one of the things that they really talk about that's kind of a good general rule is, you don't want to have like large daemon sets in a large cluster, right? Because daemon sets by definition run on every node, right? So one of the problems with the Coop proxy today is it's a daemon set, right? So if I kubectl, not this one. If I kubectl get ds-n kube system, right? I've got a Coop proxy running on every kubectl get pods-n kube system, right? So I can see I've got a Coop proxy running on every node, and I can logs it, kube system, right? And I can see not only is it running on every node, but it's running a watch, right? So I'm running a watch here on every node, right? So that means my Coop proxy, every node in my cluster is watching a whole bunch of endpoints on my cluster. So they have endpoint slices. That's, I guess, one of these. This is a cluster agent, and I'm not. They mentioned this as part of the solution to this problem of having too many watches, because it really bogs down the API server. But and they also mention endpoint slices, which makes it so that you don't have to pull down all the endpoints, and that helps to improve performance for sure. But there's other problems with Kube Proxy other than just performance at large scale. So like, it's really complicated. IP tables itself is just really complicated. And forget about the fact that we support so many. So as an example of Ravi made this a PR a long time ago. I don't think this has been merged yet, but we had a problem in Windows. And so the problem in Windows is that, you start the Kube proxy up and you want you want it to run at a certain priority level. And it's like a Windows specific thing to run it at a specific priority level. And it doesn't affect the Linux people. So you get these really weird long reviews where you've got Linux and Windows and everybody like sort of trying to prioritize, where's the pull request is here. I thought there was a pull request somewhere in here, but I don't see it. Yeah, that's weird. I do not see the pull request. I thought there was a PR, but I don't remember where it is. So here it is. Here's the pull request. So exactly. So you jump into the code base for the Coop proxy code base, right? And you wind up seeing that there's options that conflate all these different. So the Coop proxy has an IPVS implementation, an IP tables implementation, and a user space, and a kernel space implementation for Windows, and as well as Linux. So it has all these different ways it can run, and it's all coupled in the code base, and we'll look at that in a second. And so actually, we can just open Gitpod up and wait for it to come up. Gitpod's my favorite new tool. I use it all the time. So you have provider-specific options that are all coupled at the same part of the code base. and we can look at that in a second. And then to look at a few other issues that are kind of typical to come across when people run into problems, like another typical issue that might get filed. Let's load this one up. Port ranges. Oh, this is a new one. Well, this is actually, I don't think this is, I don't know if this is officially a huge problem with the proxy as it stands. But this is just one of the issues I wanted to mention that folks are working on. Pramesh is working on this to the idea of supporting like a range of ports. And there's all sorts of technical complexity around that. But it's not one of the motivations for KPNG specifically. At least I don't think it is. Mikhail could correct me if I'm wrong.
No.
Yeah. So and then here's another one, right? So this is an interesting one, right? So because there's so many different, like Coop Proxy can write rules using IP tables. It can write rules. I should probably show you this. So like, if I go into a node here, let's see. Let's go to this is a cluster. This is an Antrea cluster, right? So if I go into any one of the nodes, kubectl get nodes -o wide. If I just SSH cap v at, I named this cluster after Perry, but he's not here today. If I'm going to go root, if I go IT tables -save, okay, you're going to see that there's tons of IP tables rules that are written for me by Coop Proxy, right? So, I could, save this to a file, right? And I can open it up. Right, and we can look and we can see that, like, for every service, right? Every time I make a service, right, I have all these endpoints that get created. I have these, here they are, right? So you can see each one of my service winds up going to a bunch of different endpoints, right? So and there's a probabilistic load balancing to each endpoint. So there's like a 50% chance it'll go to this endpoint, and then there's a 100% chance it'll go to the endpoint below it, right? So it does this sort of ordered probabilistic load balancing. So this winds up becoming very difficult to scale. Now this is just IP tables, so IPVS kind of solves this, and NF tables and different providers solve this, have solutions for this. But the fact is that, like, there's just a lot of different ways to implement a service proxy, right? And even if you were to say that there's one great way to do it in Linux and everybody should just use that same way, we also have Windows, and Windows is a totally different operating system, and so we can't use the same mechanism for load balancing in Windows as we do in Linux. And and then there's
AJ,
yeah,
folks are just asking you to increase your font.
Oh yeah.
Thank you.
Yeah. You're welcome, Ricardo. Okay. Here we go. So let me look at the questions. I've been ignoring you all. Yeah, what's up, Choco? Does that look better? Let me know if this looks better. Okay, I'm gonna keep going. Just go ahead and interrupt me. I'm totally down to be interrupted here. So, Suresh, why do we name it Coop Proxy? Oh, this is cool. So this is the first time I've ever used these little bubbles. But see, I can click the bubbles, and yeah. So why do we name it Coop Proxy? What was it proxying? I think that the reason it's called Coop Proxy is because, so I don't know. Like, it's not like, I don't know if Tim or Brendan Burns or anybody's here that could really answer that historic question. But
It was a proxy at the beginning, the user mod. It was really TCP and UDP proxy.
Yeah, it literally was like a real time, like, so if you look in there, that's what I was thinking. So if you go into the user space proxy, this is Mikhail, this is the original one, right? The user space proxy, right? And so if you go into proxyer.go, then you'll see it like makes a Go function, right? So if you do why is it showing me a diff here? So if you go in here, how do I get rid of this weird thing? Okay, there we go. It's like trying to like
increase a bit your font. I can barely.
Oh yeah.
I'm here just to keep
This
bothering Jay to increase the font, folks. So
you're like,
you can just, yeah.
This is like, it's like Kaping. You're like the cat. You're like my cache to the to the streaming chat in YouTube. So okay, so there's a. Does it look better? So does that look better, Ricardo?
Yeah, for me at least it looks.
Okay, go func. So there's a go function somewhere in here. Whenever you, I think it's maybe this. Whenever you connect to, whenever you made a connection originally, where it would, maybe it's proxy socket. I don't know where it was, but it actually would create, proxy loop.
Look, I think for net.listen, but yeah.
Listen.
Yeah, that should be not.
Yeah, here it is.
Yeah.
See, so every single time, it used to be when this first came out, right? Every single time that you would connect through a service endpoint to a pod, there would be this like loop in Golang. It was literally a user space loop that would forward the TCP connection for you. So it was just, it didn't scale at all, right? You'd have, and so
yes, even with a lot of CPU, you had the problem that you have at most 65K connections possible. So that's got exhausted pretty quick.
Yeah. Okay. So I didn't even know anybody ever measured it. I just assumed they moved off it so quickly.
It's the first bottleneck I encountered with the Coop Proxy.
Yeah. Okay. Cool. So by the way, big thanks to Mikhail for joining us today, and Ricardo as well, because Mikhail has forgotten, what do they say? Has forgotten more about Coop Proxy than most of us will ever learn, right, or whatever. So he's kind of an expert. He worked with Ben Elder and Tim Hawken and all those people in the early days. So, anyways, that's why it's called that. It's a great question, right? Oh, still not clear. Let's see here. Make it bigger. Cool. Now that's probably big enough, right? What's up, Daniel? What are you gonna wait? Oh, gee. Oh, okay. I thought, okay. Sorry, my screen was okay. Can you crank the font? Okay, 422. Is it better now, Choco? It's good now. Okay, KR. Okay. I like your, okay. So this just didn't scale. You had to make a new one, and it's always faster when you go to the kernel. You don't have to send all the stuff back up the stack. So then they went and they built the IP tables proxy, right? And that was a huge improvement, right? So then they went, and so you go into proxy. So this is the first one. So now you get out of here, and then you go into the IP tables proxy here, okay? And now we have this this other implementation, which is much more performant, because what does it do? So let's look at what it does. So what it does is it makes these rules, and the IP, as I'm sure we all know, IP tables is in the kernel itself, so you don't have to go all the way up to this user space program and forward packets manually one at a time. It's just done right at the kernel level, and I guess, since Ricardo's here, he's probably going to say BPF is even faster because you don't even have to go into the kernel or whatever. But none of the Cilium people are here, so we don't. So nobody's going to say that, I guess. I don't know. But there's that whole thing. But I'm not that good at this stuff that I would really have an opinion on that. So, anyways, it makes these load balancing rules, right? So rather than starting a function for each one of these, you hit the kernel, and the kernel quickly follows these rules. So we go from the Coop service to the Coop service endpoint, and then we probabilistically land in whatever one of these endpoints is, right? And we'll walk through one of these in detail. I just wanted to show you, this is an Antria cluster, and some people actually kind of sometimes ask Antria versus Calico, what's the difference? From a Coop Proxy perspective, there's not a huge difference, except one thing, which is that Calico actually makes IP tables rules for network policies. So if I say kubectl, let me make sure these aren't here. -f nginx ds.yaml kubectl delete -f nginx.
Increase your font, Jay. Again.
Yeah. Good. I'm so bad at this font thing. I'll get better at it. Okay. Keep going. Bigger.
That's good now.
Cool.
At least
Yeah.
for me, it's good.
Yeah. So if I go in here and I say, let's go and let's, I think this is a kind cluster. The other one was a TKG cluster. This is a kind cluster though. So to exec into one of these, I'm going to have to exec into the container. Right. So Docker PS, Docker exec -t-i, right, bin sh. Okay. So let me get in here and, so I have the same thing, right? So I'm in a Calico cluster, and you can see we have a bunch of the same types of rules, right? The same service. So the service load balancing rules are the same, whether regardless of what CNI you have, your Coop Proxy is doing what it does, right? And in each case here, we're running IP tables Coop Proxy, so we have IP tables rules in both of our clusters. But there's a little slight difference, which is that if I was to say, for example, rerun this command that I ran, IP tables -save F1, and then I was to say make create these network policies, right? Create -f. Okay, so now if I go create these,
I think you can unclick Suresh too. No.
I could what?
Unselect Suresh.
Oh yeah. How do I unselect him?
Because it's over your file, so.
Oh yeah. Okay, sorry about that. Yeah. Cool. So Suresh, you had like 10 minutes of fame there, huh? So what was I doing? I forgot. Okay, here we go. So now if I do IP tables save F2, okay, now I could diff F1 and F2. Yeah, you see how there's all these new rules that were made, right? So because I had a network policy that was on a Damons set, that means that this particular node that I'm in has all these new IP tables rules that were generated by Calico. So like, for example, Calico implements network policy in IP tables. Now, meanwhile, Antria, okay, if I go back here, Antria does not implement network policy using IP tables. It implements them using Open vSwitch, which is a totally different way of doing it. But there's an equivalent command I could run in Antria where I would see the network policies implemented. None of this is really relevant past the point of just the fact that, okay, so, in this case, we're running two clusters. The clusters have totally different CNIs. Both of them have a Coop Proxy running. And in both of those clusters, there's a lot of IP tables rules. But one of the CNIs is actually adding new IP tables rules on top of it. If we were to use a different run Coop Proxy in a different mode, like IPVS, then we would still have some IP tables rules because Calico would be writing them. But for example, with Antria, we'd have no special IP tables rules. Okay. So that's the way all this stuff, because people sometimes get confused about how IP tables and IPVS and all that stuff interrelate with the proxy. So that's it. Depending on how you run Coop Proxy, you've got different, it's going to implement the data plane differently. And that's why, so there's a lot of complexity in the current code base, and it's very hard to add features to Coop Proxy at this point. It's very hard to like add generic, to reason about its performance generically. It's very hard to scale it to thousands of nodes because you have now a Damons set that has to watch all these endpoints. And so that's why we have Kaping. So I'm going to jump over to and Ricardo has a good post where he went through some of this. So Ricardo has this post here, if anybody wants to read it, where he went through the whole. This is a really good diagram of the different IP tables chains and the post-stratting, the forward, the input, and the pre-routing, and then how the different like rules inside the chains wind up sort of routing you in between from the kernel to a local process. Anyways, so Kaping takes so we got to look at the code base already because of that question that Suresh asked. So now what Kaping says is like, well, why don't we have this huge glob of different implementation details here. What if we took the generic stuff and that every proxy needs to do, right? And then we kind of, and I have a diagram of this here. I think it's here in my, yeah, here it is. So the idea behind Kaping is, why don't we like why don't we separate the part that's watching the API server, right? So like as we saw in the when I was in my, yeah, when I was in here, right? As we could see, as soon as you start the Coop proxy up in one process, it's doing a whole bunch of like watching of the API server, but it's also doing like low-level network stuff too, at the same place. So like, why don't we decouple those? So now you don't have to run a daemon set on your cluster to watch the API server anymore. You've got a decoupling where you've got one thing that's doing the stuff up here, and then you've got other stuff that's doing the back-end stuff. So the programming of these IP tables rules, right? And just again, to be concrete, again, remember we SSH in here and IP tables dash save all the sudo. Yeah, there we go. All these rules, all the logic associated with making new rules every time you make a new pod. So the new state of everything is put into this sink, okay? And let me make this bigger. I'm making it. Let's see. Here it is. Yeah. So let me know if this image isn't. I think this image is still too small. So let me. Yeah, that's better. Oh, look at that. Nice and big. Okay, so the point of this whole thing, right? So you go in here and you're able to like just watch the API server with maybe one pod, and then you could have a totally different set of pod. You can have an agent running on every node. That's fine, and it's maintaining the routing rules, right? It's maintaining these rules, and that's being done on a per node level. But that doesn't put any extra load on the API server. So it's you can have, you could theoretically have 1 million of these nodes and you wouldn't have any extra load on the API server. So that's kind of the two, that's the big selling point here, right? It gives you logical decoupling, but it also gives you a performance, a huge performance boost, a theoretical performance boost, which is very obvious to perceive here, right? So now if we go, so now what that would allow us to do, for example, is we could actually look at as an example. So if we go to Ricardo made his own backend for Kaping, and it doesn't have anything to do with he made it specifically to make me happy. See, so he made his own Kaping backend, and all it does is write these IPVS rules. So this is not IP tables, this is IPVS, but it's the same idea, right? So it goes in, and if we go here, right? If you go into where's our diagram? SVG, here it is, right? So he implemented this part. Okay. He implemented this part down here, and he was able to just talk to this local sync, and all of the other stuff was done by Kaping, right? Now Kaping comes in tree with an NF tables implementation. So it turns out NF tables, actually Ricardo and Mikhail explained this to me this morning. I didn't know this. NF tables is actually the underlying implementation. Nowadays, I guess everything uses NF tables or can use NF tables under the hood in the Linux kernel for all this stuff. So IP tables is like the old way of writing these firewall rules. But okay. And before I jump over to that, I just want to say one other thing. This was made by Lori. the subproject, the Coop Proxy subproject, we have this goal of like trying to figure out how we can wrap our head around all these Coop Proxy problems, build a community around them, and so on and so forth. So if anyone wants to help with the sort of day-to-day grind of going through issues, figuring out what's wrong, figuring out whether we can do something about it or not, we have lots and lots of issues to go through, and we meet up every Friday morning at 8:30 PST. So this is just an example of like some of the issues, and you could see like, a lot of them are configuration related, right? So for example, this is one thing that a lot of people have been asking for, is the ability for the Coop Proxy and the Kubelet to have a load balanced client, right? So that you don't have to do a big dance around sending Coop Proxy a load balancer endpoint for the API server. And so that's like one issue. And, part of what it takes to just help with this stuff is just to be aware and be available in the community to ask people what to do with these issues and follow up with them and stuff. Some of them are performance related, like people do funny things with their cluster. We have some situations where we have proxies implement different logic differently. So for example, in the Windows Coop Proxy, we haven't fully implemented terminating endpoints, which is, when a pod goes down and a service has an endpoint, flagging it as terminating, so load balancing stops against it. So there's a whole different like range of stuff. And even if you're not a deep networking person, there's a whole bunch of stuff that's just related to like configuration, right? So for example, we have this priority flag issue that I mentioned earlier. We have config map reloads. This is an issue actually I filed, but it's an issue of the fact that in Coop Proxy right now, you don't actually hot reload. So if you change the config map, so the way you configure Coop Proxy right now is through a config map. So if I kubectl get cm-n kube system, if you look here, then I have a config map and I could edit it. kubectl edit cm kube proxy-n kube system. So this is how you configure Coop Proxy right now. It turns out that it accepts a lot of flags though, but none of the flags really do anything. They're used to generate a kube config. So like we're trying to figure out, but it's related to the component config group, like what to do about the fact that people are kind of confused by this. But for now, just know that if you change something in here, for example, if I decided to go in here and I decided to run, say I decided to, I don't know, what would I change? Maybe I would change, say I change the UDP idle timeout. Let's say I make this 10 seconds. Kind of a weird value. Let's say I make it 1 second. If I was to do this, okay, this would not affect anything, right? Until I restarted my proxy, okay? So that's just one example of, and so we don't really know what to do with this. It confuses people because they change the config map and they expect, because it's Kubernetes, that things will be sort of reconciled, but in some cases that's not the case. You actually have to restart the Coop Proxy as a daemon set. There's a big debate around whether that's the right thing to do or wrong, and so on. So, but anyways, I just wanted to make sure everyone knew that we do have a group that's working to try to create a consensus and a community, a small community of people who are taking action to try to help organize and fix these things, and help each other to triage these things, because it's not something any one person can do. So join us Fridays, 8:30 a.m. PST. So we have a, we can ask in Slack about other details and stuff like that. Okay, so where were we? So Kaping. So we have, now we can go over to Kaping. So I will show you how to get started with it. And then we will sort of dive into an interesting problem that we just actually found, and we're not quite sure where it came from, but let's see. So so we have a script in the Kaping repo. So you can check out Kaping at Kaping. You can check it. It's on GitHub, and it's under Kubernetes SIGs. Oops, I meant to go to Kaping. Kaping. There we go. All right, so it's under Kubernetes SIGs, and you can git clone it, whatever, and you should just go into the hack directory. And in the hack directory, we have, let me make sure I'm up to date. No, I'm in the wrong branch. Okay, let me get to master. Let me stash all this. Check out origin. I also, we had like a little fire drill around how to actually configure Coop Proxy. It's kind of interesting, and I wanted like draw like a little diagram about that. I guess I'll just poll y'all. Would you all prefer to dive straight into Kaping, or would you prefer to, before we do that, take a look at how Coop Proxy is configured? Because there's an interesting chicken or egg problem that sometimes we run into that confused me about how it's configured to talk to the API server, even though there's no actual endpoints before it comes up. If there's no opinion, we're just going to dive into Kaping. Okay, no opinions. So I'm just going to go straight into the Kaping stuff. Am I good on the screen, Ricardo, you think?
What? I can't see your screen.
Looks good?
Yeah.
Cool. Okay, so we have a script, and it's just Kaping local up. And what it does, okay, is it builds the container. It'll push it for you. So it should be easy for anybody to get started and even work on the source code hack on it if you want, make a PR. But so we make a little role binding that allows, so this SA makes it so that Kaping can talk to the API server. And then we create a deployment. So if you look in here, Vim Kaping deployment, if you look in here, it's actually a daemon set. So this here, right? We actually run it as a daemon set. It's important to realize you don't need to run Kaping in this way. You can run it in a way that it's not a daemon set. You can have a daemon set just for the data plane and a pod or a deployment for the API server interaction. But of course, for testing, there's no need to do that. We're just running four pods on a 4-node cluster, right? So this is just a kind cluster. And so we when you launch Kaping, you've got the Kaping server, and then you've got another container that does the data plane stuff, right? So these are two totally independent processes, right? So this Kaping server is going to it's going to publish whatever the state of the API that needs to be listened to by the data plane stuff that needs to write the individual NF tables rules, right? So let's run that and let it start, and we can dig into the individual containers once it starts. There's nothing I need to pull or rebase against, is there, Mikhail?
Don't think so.
Oh, that's weird. Something changed.
I just added a few utilities, but
oh, you added that. Well, I do need that. Okay. See, I knew there was something I needed. Okay. So here we go. So, all right. So we're deleting the cluster that we had. So again, this is kind of low-level stuff, right? Obviously, if you're a user of Kaping, you wouldn't need to go and build this image and all that. But it's not something that's production. Like, it's not. We don't have releases and stuff around it yet. It's still. There's a KEP for it. You want a diagram, Suresh? Yeah, let's do a diagram. I just wanted somebody to ask me to draw a diagram. Somebody asked me to draw a diagram. So when you're so one of the interesting problems with Coop Proxy is, and so this is, let's see if this works. I got this. Ricardo showed me this thing today where you can draw. Let's see if it works. It works. Okay. So when you have Coop Proxy, right? It sits here, Coop Proxy, right? And does anybody in the audience want to take a guess at, see if y'all have been listening, what does the Coop Proxy depend on for its data? It's a very easy question. The API server, right? So Coop Proxy goes and it talks to the API server. API server talks to etcd, right? etcd is here, okay? So when Coop Proxy comes up, right? The next thing it needs, and let's say we have our nodes in our cluster. So let's say I have two nodes, one node here and one node here, right? This is my first node, and then this is my second node here. Okay, so node 2 and node 1. Say I have a 2-node cluster, right? This is a horrible drawing. It makes no sense. Okay, here we go. That's better, right? Okay, cool. So if I have these two, right? So this guy is also going to have to talk to the API server, right? So so this is the regular scenario. Now there's a couple of problems we'll talk about here. When I start Coop Proxy, that means that both of these need to have some kind of a certificate to talk to the API server, but they're also going to have a route to the API server, right? Now, whose job is it to make, now most of you probably know that every cluster has an internal service endpoint, right? So if I go here, if I say kubectl get service -a, what? What? kubectl get service -a. Here we go. Okay. If I do that, every K8s cluster you've ever seen in your life probably has this default service, right? So this is the internal 10.96.10.96.0.1 service, right? Okay. Now, you can't, if you're running the Coop Proxy in a pod, right? You can't easily access this service because the Coop Proxy hasn't created any of the there's no DNS, there's no DNS to this root yet, and there's DNS to the root, but the root it's not routable yet. So to a API server endpoint. So because whose job is it to make those endpoints? Coop Proxies. So you have this chicken or egg problem. And so what you can do is to make a development environment for this. Normally what you would do, right, in the real world, most of you folks, you have like a load balancer. So normally we could get rid of this, right? You don't have this. Normally what you have is you have a load balancer, right? And all of your traffic normally is going to go through a load balancer. So, so you could kind of do that, right? So you could have your Coop Proxy go to your load balancer, and then your load balancer knows how to get to your API server, and you have a certificate, whatever you have. So you could do that. But in this other chicken or egg problem where you don't have a load balancer, right? What we've got going on here is it turns out that in Docker for our development environment in kind. Oh yeah, I am handling. Yeah. So in Docker, I have an API server running on this node, right? And it turns out that in Docker, I can rely on there's a DNS name for this node, right? So if I go into one of my nodes here, let's go to our kind cluster. I have a kind cluster over here. If I do Docker inspect, where's the DNS name? Docker.
It's Calico.
Oh, it's the inspect. Okay.
It's Calico control plane, and that's the name.
Yeah, Calico control.
Worker.
Calico worker, here it is, host name, right? So like in a kind cluster, right? I have a host name here, Calico worker, right? So what I can do is I can have my Coop Proxy, because I need to access the API server through a valid DNS, through a valid host name, right? Because they don't let you do that insecure access thing anymore. I can go through the DNS Calico worker, and then that DNS will send me to the API server. Okay. So and the same thing here, right? Well, actually, in this case, it would not be Calico worker though, right? Because we actually access it through the Calico control plane. Okay, Calico control plane. So we hit the Calico control plane, and then the control plane is the TLS. That's the TLS for the API server endpoint. So this is kind of an idiosyncrasy about setting Coop Proxy up, because any other daemon set that you were to set up would be able to, well, you'd still need to access it securely, but you can use the internal Kubernetes service account to do that, right? And so we can still use the internal Kubernetes service account for Coop Proxy to access these. Yeah. Yeah, exactly. The internal. Well, I meant the default service account to access the internal service, right? So that's how we are configuring these development environments for us, so that we can just run a script and then have thing running in a container. So, and for those of you that are interested in Windows, our solution to this is right now in Containerd is not running the Coop Proxy in a container at all, and instead running it as a process on the Windows system, because there is no easy way to get to the default to the Kubernetes API server from Coop Proxy running on Windows if you're in Containerd, because you don't have a bridge. You don't have a bridge for free in Containerd like you do in Docker. That's a Windows thing, though. I'm not going to get into that right now, no, because I know you all don't care about Windows. So, anyways, let's see. So let's see. So we should have kubectl get pods -a. So this is the issue. We just got this up and running, and we actually found we might have introduced a bug in the past couple of days somehow. We're not sure, but we have Kaping up and running. So let's just take a look at what's running inside of it. -n. Okay, so if I do kubectl edit pod that -name kube system. Okay. Here it is. Here's our running container, right? And if I, oops, what did I just do? kubectl, if I exec into it, t-i, kube system.
You can alias alias k equals kubectl -n kube system if you want.
Wait, something weird happened here though, because I exec'd into the Kaping container. Shouldn't it have told me that there's two containers, right? It just gave me the...
It's using one as default, as it said, defaulting container name to Kaping.
Yeah. What is it, Kaping NFT?
It's not like logs. NF tables. Okay.
Oh, NF tables?
It's the same image anyway, so...
Oh, it's all in the same process.
Same image. But...
Describe... Oh, it's the same image. I see what you mean. So I'll be able to run the same commands and see everything.
Yeah.
I see what you mean. Okay. Get rid of this. So let me open a shell up, and I'm inside of my... Just the same way, like we could do the same... Like, so this is... So we are inside of the NF tables container, and we can run. I guess I could just run this command on the Docker node, right? I don't really need to run it inside. It's better to run it on the node, because see over here when I was showing this to y'all, I was in here, and we were SSHing into nodes, and we were doing IP tables save, right? And then we were sudo IP tables save, as Mikhail reminded me. So, okay. So we were doing this. Now, if we go here, it's the equivalent, right? So if you do Docker...
Yeah, you have a script just before. Just do a cat setup. Yeah. Just so you can cut and paste what's needed to access NF tables.
Is this going to fix the problem we had?
That's just to set up the masquerading for normal pod access. That's another thing.
Okay.
Just the apt update and install is what you're going to do next at the next step. So.
Okay, you want this?
Just do your Docker exec. That's okay.
Okay. Let me get in here. Do I need to do an app update or something? Okay.
Not here, but here there's that weird thing where you don't see the rules from the container.
What is the equivalent to IP table save for NFT?
It's a list space rule set. So that's the weird thing. Here it's empty, but if you go to the Docker, it won't be empty.
Oh, okay. Interesting. So, but we're in the Docker node. Okay, weird. So you're saying
I think it's Docker specific.
Okay. Interesting. So I didn't know that. So I can't do an NFT list. Does anything work in here? I do IP table save. Oh, I'm not root. What?
Yeah, there's something. Maybe it's a privilege, or I don't know.
Oh, that's weird. Maybe this container.
It's probably the Docker nesting that could be doing that.
Interesting. Okay, so we can't. Okay. All right. So, but you're saying if I exec into the NFT container, I'll be able to do it.
Yeah.
Maybe because you set those cap privileges.
In the Docker. In the capping proxy control plane or worker.
Yeah. In the
Docker
actual
exec.
Yeah.
Yeah. Docker exec, not kubectl.
Oh, I was doing Docker. Oh, really? Okay. So Docker. So you want me to Docker? Well, if I Docker PS, this is what I got. So how would I Docker exec into a?
It's Docker exec dash IT and then capping proxy worker, for instance. You can use the names at the right.
Okay.
Because those are always the same. So.
That's what we just did, though.
You got in kubectl, so it's not the same thing.
Okay, I see what you mean.
So that's where you want the apt update and install.
Apt get, okay. All right, so we're running apt get update inside of the Ping containers. So these are the the moral equivalent of our Coop Proxy containers. Yeah, that was fast. Okay, do I need to install
an if table?
Okay.
And if tables.
All right. Aren't I in the NFT container? Oh, but I'm in the other one possibly. Okay. NFT list. Did it list all?
Rule set.
Rule set. Yeah. Okay, here we go. So this is the equivalent of what we were doing in IP tables, right? So these are all the rules that are being written by NFT. And you could see they're a lot easier to read than the IP tables rules, right? So for each chain, I guess we have these routing rules. So let's go. Where's like our core DNS routing rules, for example?
Well, that's the thing we've seen before. It's they are in reject mode, so they are not ready yet.
Okay.
In your cluster.
Oh, okay.
So as they are not ready, the endpoints are not added by Kubernetes, so they are not added by capping.
Ah, good. Let's show that.
So that's why you have it in filter.
Cool. Okay, so this is interesting. So as you look in here, see, as you can see here, the Coop, in our case, core DNS has not come up. It's not ready, right? So if we go in here, they're not. We don't see a rule for them. So the question is,
filter SVC at the middle.
Oh, there is a filter.
Filter SVC, Kube System, Kube DNS. Lots easier to read than
filter service.
So don't scroll. It was at the middle. It's now at the bottom.
Okay.
The last 4 lines.
Last 4 lines. Chain filter service here. So this would change. So this would no longer be a filter if these were.
Yeah, it's a filter because we reject the packets as there's no endpoints.
Okay. Okay, cool.
But if you look at the service default Kubernetes, which is the access to the API, you have a DNAT rule instead of a reject.
TCP port. Okay, cool. So when you read one of these from left to right and an NF tables rule, can you read this to me like I'm 5, like left to right? So TCP.
It's matching TCP protocol, destination port 443.
Yeah.
And DNATs that to the actual endpoint. We don't care about the counter.
Okay. No counter. Okay. So so it's saying when we hit this chain, we're going to destination NAT and then go to 172.18.02.
One first big difference is that it's what you have just above. You can use maps to jump to rules in NF table, so it's much faster than doing a sequential read of rules in IP table. So yeah, we have a direct map from the service IP, so the .0.1, to the DNAT rule.
Yeah, and to compare that with what we were doing in IP tables over here, right? We had where was it?
You have to go through in kube services and match the service IP.
Yeah, exactly. So sudo.
And hope that this gets masqueraded correctly.
Yeah, so if we look here, if we look at the same thing in IP tables, right? We look at the complexity here, right? 10.96.0.1, right? We can see there's this, that's this destination rule, and then we go to the kube mark mask, and that's where it gets masqueraded. That's where it gets masqueraded. Well, I already showed it to folks before, but we could see that it's much more difficult to read. So going back here, so exactly. So and if just to complete the circle for folks that are wondering, why is this working and why is this not working? Why is the default service rule working, but the kube DNS core DNS rules aren't working? These are on the host network, right? So, or these are rules that are these are services that are mapping directly to like nodes on our cluster, right? So if I say
just services that have endpoints.
Yeah, they have endpoints.
If you do kubectl get EP-A.
Yeah, we'll see that we have an endpoint for our service, but we don't have any for our. Yeah.
So exactly. KubeDNS is correctly rejecting connections, just like a service that's started on a host. Yeah. That's how Kubernetes specifies that with legacy Coop Proxy too.
And the weird thing is that, well, actually, it's not weird. If we look at our core DNS pods, they do have IP addresses because they're running, right? So kubectl get pods -oy and kube system grep core. Right? You can see that these got valid network interfaces. They got IP addresses. The problem is they didn't come up. So let's go look inside and see here why these pods didn't come up. So kubectl logs. Okay, and we could see here that for some reason these pods are not. The core DNS in our cluster is saying I'm not ready yet, and the reason I'm not ready is because I can't access the internal Kubernetes API service, right? So going back to our diagram, we have essentially, we've got core DNS, and core DNS is here. And core DNS is trying to access the API server through the Kubernetes endpoint, which is an endpoint that is created by the Coop Proxy itself, but it can't access it. So there's no routing rule. It's able, so it can't.
There is a routing rule, and we've just seen it, but it's not working for it, or
it's not
something.
working.
We don't know yet what's going on with core DNS. Obviously, at the beginning, it was saying that it could not connect, but we don't have those messages. See, it's at 9 p.m. 8 minutes, so that's quite a long time ago.
Yeah. So,
maybe it was just a minute ago, but anyway, it's not accessing it, but it's not clear why.
Not clear why, yeah. So we just hit this bug just now, right before the demo. So it's kind of like, well, that's kind of the point of TGIK, right? Is we kind of do things we kind of run fast and loose. So I guess the question here, Mikhail, is do you think this is something that we should is there something we could do inside of KPNG to try to debug this or try to get this working? Or is it?
I already tried with an Alpine Linux container, and I can access the Kubernetes endpoint. So that's kind of weird that it doesn't work for core DNS.
Mm-hmm. Is it?
Maybe we can try to remove the pods to see if there's kind of weird race condition, but.
Okay, let's do that. So, oh, what? Oh, yeah, that's right. Dash replicas. Okay, so now we're going to bring them up. Let's bring up 4 of them. Okay, cool. So now we're going to try to fix this problem. And I guess one idea of fixing it is maybe
Just
something
running through hypotheses, but
yeah, this is just we're just hacking here, so we don't know. So maybe if we start these core DNS containers a very long time after KPNG has already started, maybe that will solve it. Looks to me like we have the same issue.
Yeah. Well, at least that would be consistent.
Do you think this is possibly a kind? Whoa, that doesn't look the same. Wait, this looks like it's...
They're the same, but there's also the problem that it's not able to communicate with his... It's trying to get another DNS server running.
Okay, it's the same error though after it. Okay, same error.
You're in the source.
Yeah.
So you can actually. I've set. Did I push? I'm not sure I pushed it. No, it's not pushed. Okay, I just pushed it. So you get an Alpine deployment.
Okay. Oh, this is Ricardo's. I'm in the... What? How did I end up here?
You are inside Kubernetes repo.
Yeah, I'm in the wrong one.
Yeah. Don't push to the main repo.
Yeah, I was pretty sure I didn't push like.
I'm like, what's going
10
on?
megabytes.
Where is?
This is a reason why we are trying to move Coop Proxy out of stage also. Out of the tree.
What? Where am I? Okay, I see. I put it in Gate as prototypes. So this is my repo that I have, where I have all my experiments that I do. So KPNG experiments. And for some of you all, okay, here we go. All right, so let me go to hack. There we go. And now I'm going to do my used to KPNG local up, right? We'll get pull. Get pull -- rebase origin master. What do I have in here? Oh my God, go mod. Why does it keep get stash? Okay. Alpine deployment. What's that all about? Okay.
It's just to add a toolbox.
Okay.
That we can actually use.
Okay, so
You just apply it. Kubectl apply.
You want me to just apply this? There's no actual. Okay.
Yeah.
Yeah. There's no code changes. I got you. Okay.
No,
we're gonna-
no code. It's just I was beginning to try to go through hypothesis. So
Okay. So our next hypothesis here is that maybe other.
well, I think that was the first thing to check was do we communicate through the service IP with the Kubernetes endpoint?
Yeah.
So that's what I wanted to check, and
Oh.
that's where I've seen there was the problem with the masquerading that's required to access the internet. So that's why there's the setup. If you do, you won't be able to ping, and you don't have DNS working since core DNS is not working.
Yeah.
And you don't have curl, so you need to install curl. And if you want curl, you need to download it. And so you need to get the masquerading working on the node.
Yeah, that's true, because we can't even get to the package repository. Yeah.
Yeah.
Okay, so that's why we run out of script.
There's the setup, yeah.
Okay. All right, so this script here, I gotcha. Okay.
You need to run that in Docker exec of your worker. The easiest way is to look at the node that has Alpine.
Okay, I see. Okay. Oh, so you run it on the Docker node.
Yeah.
You just run it on all the nodes, right? So Docker. What did I do? Okay, so
I don't know.
So you okay? So
now you need to pass the script.
Oh, I can't. What is this? Ubuntu apt-get update -y.
You already have a script, just at the top of your terminal.
Oh, so you want me to just paste it?
Yeah.
Really? Okay.
I try to make your life easy.
Every time I paste this script into a terminal, it always ends bad. I don't know. Okay.
Yeah, maybe not with the set.
All right, fine, it worked. You're right. Okay. I just wanted to do.
No EUF?
What? It looks good. Oh, it worked.
Yeah, but you don't have the last line of the script. I don't know why.
I think it's because Suresh made me make my terminal so small that now I can't. now I can't do anything. Hold on. Okay, here we go.
Yeah.
Oh yeah, the EOF. There it is. All right. Cool. Okay. So what did I just do? So explain this to me. So I made it looks like I made some NFT rules. This looks like the thing we looked at earlier. So you made a post, okay.
Yeah, we just enable masquerading so pods can reach the internet.
Okay, cool.
From the worker node, we need to do that on the node of Alpine.
Okay, pod. we need to do this on this one too then, because we don't know which one it is.
Yeah.
Okay. You know, Ricardo, one thing I want to do is go over your moving Coop Proxy out of tree thing. So maybe you can, since you're on the stream, maybe you can walk people through that. If you want to pull that up, we can show that to people. And we can maybe hack on this for another, it's almost an hour and 20 minutes. So let's try this for another 5 minutes and then we'll jump over, we'll go through that and we'll close up. I was just teasing you, Suresh. So here, Parrot. Yeah. I don't know what this DPDK thing is all about.
It's path.
Yeah, it's another way of doing networking things, but instead of relying on the kernel as eBPF does, you move everything to user space. So you say to the kernel, don't even get this packet into the networking stack, just send this to something running in user space. So I guess OVS relies a little bit in DPDK, I guess.
Okay.
I am not pretty sure. Yeah.
Okay, cool. Yeah. For folks wondering about these CNIs, by the way, since we have a couple of them up, I think it's worth just showing you, and then do you have your, while I do this, Ricardo, do you want to pull up your PR? And then I'll just, we'll hop over to.
Yeah, I think you have a huge copy paste into Antria code, right? That you were going to show.
yeah,
Yeah.
as an example. Yeah. So when Ricardo's talking about OVSC, so if you look at the routes in EndNode that's running Antria as a CNI provider, you'll see that everything talks to this Antria gateway, and this Antria as a CNI provider uses Open vSwitch. And Open vSwitch is like basically a virtual switch that runs on every node. And as you could see, what Antria does is it uses this .1 IP address that's in the pod network namespace as the virtual switch for every like container. So if you're trying to go here, like if you're so basically every container has a single gateway, and that gateway is on the node, right? So like for example, if I was to yell get pods -a, if I was to scale up the number of core DNS pods, scale system -- replicas equals, say 20. Why is my terminal frozen here? That's weird. What?
It seems to. Oh, it's deploy core DNS. We didn't set the kind of resource.
Okay, so now I've scaled this up, and this doesn't change the gateways, right? So I can rerun the same command, right? And I still have the same situation. So I have all these gateways managing the same. If I do, right, you can see now if I run IPA, you can see I have all these virtual interfaces, right? Each one for all these different core DNS pods, right? So that's the whole, when we talk about OVS, that's how that works. And if you did the same thing on Calico, on a Calico cluster, if you docker ps docker exec -t-i, they don't use OVS, they use what is it called? So you can see in Calico cluster, every pod has a network interface as well, right? And if I do route -n, oh wow, I don't have route -n on here.
IP route.
There we go. So in a Calico cluster, you'll see you have these. So that's the way the routes work. They both wind up using the same. I think they both use the node IPM controller. So your nodes kind of shard up these IP spaces for each one of your containers. But again, so this is how you actually look at the underlying CNI implementation in each of your providers. So yeah, I can just show them that. So if you look at, for example, one of the reasons, so Ricardo is working on moving Coop Proxy out of tree. So if I go to pull requests and I say author, and then you write, there's the other one we have I actually have this email pulled up here. So if anybody's interested in what it means to move something out of tree, so we kind of brought it up in Gitpod a little while ago, and I'll reload that workspace. But so all that code that I showed you earlier for Coop Proxy, right? All that stuff is in package proxy. And so in order to do this, what we have to do, or what Ricardo has to do, is take all these sub packages, contract, IP set, IP tables, all this stuff, move them into a part of Kubernetes that you can vendor from, because you can't vendor from the core part of the repo. So moving these into like staging and all that. And it's kind of a lot of work. So if we look, here's his pull request. I think you broke it up into separate pull requests, right? But like, to see why this is valuable, why this is important, Antria, and I believe Calico does this as well, but I'm not sure, yeah, Calico does it as well, right? Like, in order to implement your own sort of proxy-like logic, right, what you wind up having to do is copy sort of bits of, like there's bits in here that are copied from like Coop Proxy itself, right? And so Antria has its own proxy that replaces Coop Proxy. And so they have to sort of sync that up with the logic in Coop Proxy. But if we were to have moved to KPNG, right, then what we get is we would be able to literally just have like the Antria bits implementing this down here, or if Calico wanted to implement their own service proxy, or if whatever, Cilium or any other CNI wanted to implement their own service proxy, they could just implement this part, and then this would all be like sort of imported. Like, and I think I actually have an example in the show's notes where, as an example of this, where if you go into, where is it?
Are you looking for the cap?
I was gonna look for an example in the code of we were looking at earlier, where if you look in IP tables, actually we can just go here if Gitpod's loaded up. Let's see if Gitpod was fast enough. Oh, it's still going. Come on, Gitpod. Nobody's working on Friday. You should be faster. Here we go. Okay, it's there. Here we go. So if you go into package and you go into proxy, oh gosh, if you go into package and you go into the Coop Proxy, then you say, let's go into IPVS, and let's go into like, let's go into proxy or .go. I think in here, there's like some, like if we looked, the best thing to do, git grep topology package proxy. And then we go into IPVS. Okay, so if you go into here, package proxy, proxyer.go, yeah, topology, right? So like this stuff, and Mikhail, you can correct me if I'm wrong, like this logic that's inside of the proxy or inside of IPVS, like this logic is in KPNG, right? So any proxy implementation would just get this for free. But right now, we basically have to have this logic, inside of each one of these like directories, right? We're going to have some kind of topology stuff in there. And so there's all this copy pasting that goes on, right? So if I go in here, I'll see some topology stuff here, right? So you'll see, we wind up having to deal with the semantics of like what a service is, what a Kubernetes service is, what the topology of the service is, stuff that has nothing to do with IPVS or IP tables or any other data plane. We have to continuously copy that from one of these implementations to the other, right? So that's one of the things. And then so the KEP, I'm going to end showing the KEP for the KEP for the KPNG stuff, so if people can look at it and read about it. Let's see, what is the name of is it called KPNG? This one, yeah.
You have
cool.
it.
Yeah. So I guess the overall thing, I mean, this would be, I know everybody's like, you should read this KEP, but I think this is really one that you should read, because it's not just like an API change that people are debating, but it's a big paradigm shift. And just from reading it, you can learn a lot about how the service proxy works and how it should be working, and so on and so forth. Just from reading the comments, the infinite book of comments that's in here. So this is good homework for everybody. This has the problem statement and everything else, right? Okay, cool. So that's okay. So I'm just catching up with the questions now. Is it possible to avoid context? Oh, my font is small again. 525. That was okay. Well, okay. So use the cooked view for Markdown. Rich diff. Oh yeah. Like here, you mean? I mean, I think we're probably kind of at the end. We've been doing this for an hour and a half, and I think we've gotten to go everything. Does anybody want to have any questions or anything before we go? Because usually I'd cap it at the hour and a half, but I always like it if there's anything else people want to look at or hack on or anything. I'm happy to dig into something else. Or Ricardo or Mikhail, if you wanted to bring up anything or show anything.
I think I'm fine with that, Jay. You did a great job deep diving into the code as well. And just when I ask for folks to join us while we try to rewrite Coop Proxy things as well, right?
You could go in the capping pod.
You want to go in the capping pod?
Yeah, and so not here you. Let's forget about this this problem. So in the capping pod, yeah.
Okay, so we're going to jump back into our capping proxy here.
Yes, and if you do capping dash node log, for instance, capping dash without space. It's or is it an older image with a cube something? Yeah, maybe it's a cube proxy. Just start with cube then, if it's not capping.
Yeah. Cube, like this?
Yeah.
Oh, yeah, okay.
Yeah, okay.
Yeah.
So here you have node log -h, so I'm sure there should be the target flag. Yeah, that's target. So it's Coop Proxy node log -- target Unix // I need to remember the name exactly that we've set. Depends on the version you have.
Oh yeah, so this will give us all of the. So what we're doing here is we're gonna use the. So we're gonna Kaping has this. Because of this. Let's go back here. So because of this here, we can from inside of this Kaping pod, we can just look at the data plane stuff that needs to be done. Right. So it gives you all these nice debugging utilities because of this decoupling, right? All these things are separate programs. So what Mikhail's showing us is how we can sort of look at the node level logs for the proxy from inside of one of these daemon set pods, which is for all these issues here. For context for folks, the biggest problem with these issues, right? People will file these issues and it's really hard to figure out what's wrong, because in order to figure out what's wrong, the Coop Proxy logs are there's a lot going on in there. It's doing a lot of different stuff, right? And So we have these individual like utilities that people can use to get individual information really easily for their services. So anyways, what am I doing for the
so
socket?
/k8s/proxy.sock, I think. That should be that.
Is it just k8s or k8s.io?
K8s.
Proxy.sock, right? Yeah, okay.
Yeah.
Okay.
So that way you've connected to the capping instance that's watching the API server, and you're getting the node log. So the node log is the node level model. So that's the simplest model we have in capping because it doesn't have all the information required to make pod selection, topology, and things like that. You just have the endpoints.
Okay,
and
so
what you can do in the bottom terminal.
Yeah, scale something. Okay.
You can do kubectl expose.
Okay, cool.
Expose, deploy, alpine. Yeah. Dash port. Let's say 80, whatever, just to show. It's just one part is whatever. Anyway, we don't. Yeah.
Okay. So now is it going to do something?
You already have it.
Oh, did it go faster than I? Okay. So can I just do another?
Yeah, you just got the diff. And you
Where is
have
it?
to. It's regv at, and you have a timestamp. So it got a new service from the service side, path default /alpine at the top of your screen.
Okay, let's get rid of it. All right, so there we go. So I deleted it. So that's this minus, right?
Yeah.
So this is cool, right? So like I can log this, and then every single time an operation is happening at the data plane level, I can see it. So now what I can do is I can now expose this port again. Okay, nothing behind my hands here. Here we go. There we go. Okay, cool. So now you could see this plus, right? So I can continuously just view the diffs of what's changing in my cluster from the service perspective. So like, for example, imagine you were on a real production cluster, maybe a 50 node cluster, and you were trying to figure out whether there was a bug in your proxy or whether there was a bug in the way it was writing rules or whatever. You could see, you could run this, whoever's seeing the issue could create their app, and then you could run this, and then you could just capture the diff of all the changes that happened from that point, and that would be all, and nothing else, and you could capture that per node very easily, right?
Yes, and at the beginning you have the whole state.
Yeah,
when you started.
At the beginning you have the entire state from you started. Now in Coop Proxy that's not the case, right? There's no way to get in Coop Proxy the entire state from the starting point, in this way.
You can't get in between ever.
Yeah.
If you stop the node log and you do the global log, you'll see the. Let's say you see there's a trouble. Oh, okay. You want to show something else?
No, yeah, go ahead. I was just going to mention in Coop Proxy, if I get the logs, I've got everything in here. It's not separated out, right? And so I could increase the verbosity, and if I increase the verbosity, I will see the IP tables flags that are being set and all that stuff, the commands that are being run, but the state is not, the model of the system is not separated out this way. So anyways, yeah, go on.
Yeah.
Go on, Mikhail.
So now you can let's say you see that you don't have your endpoints. You expect an endpoint for the Alpine service, for instance, and you don't see it. You've queried the local node, the local model, and you don't see your endpoint. So you want to check if it's a problem from the global model that's at the top of the drawing.
Mm-hmm.
And so to do that, you can just query the global model with global log instead of node log.
Yeah.
So if you just stop at the node log and just replace it with global log.
Okay, so now what we're looking at is, so we were just looking at node level log. But now, since we're running both the node level stuff and the API server watch, we're running that both in the same process. That's not a requirement, but we are doing that. We can do global log. And now we can see the other part that I just showed you that was also in the Coop Proxy logs, but just that, right? Now we only see the Kubernetes specific stuff, the changes that are happening at that level, and not the stuff that affects any individual node, right? Because each individual node will have its own operations that it has to do to,
Yes, for instance, if you suspect a problem with the topology implementation, you could have a look at the global model to see if you have all your endpoints you expect, and then if you don't see them in the node log, you can say that you have a bug in the topology implementation, for instance.
Yeah.
And then just one last thing, go back on the terminal.
Okay.
And then you can say, okay, I have a use case in my cluster that's not working. You can stop the global log. Yes, and now you
like that? Is that what you're talking about?
No, that's not. No. Just do PS aux, so we can get a copy paste quickly the no dash.
Oh, there we go.
Okay, so we are going to do the capping cube.
Okay.
So that whole thing, just don't get two API. Yeah, we just replace that with two file.
Yeah, this is okay. Yeah.
And yeah, okay.
So what we're doing here, right, is this is another thing. So again, when we look at the way we normally run the proxy, right, we start this one process and it's storing in memory all the state of the watches for the API server. It's storing all that in memory. So in this case, where's the file though?
You can stop it.
Oh, it waits until.
Yeah, because you have a date. You have your global state.
Cool. So now I've got Matt Fenwick would really like this. He loves like this stuff where you have like
VI.
Yeah. Okay. So, okay, cool. So yeah, what it's done is it's aggregated. So those of you that are familiar with CNI providers will be sort of like, okay, because like Calico and Antrea do this for network policies, right? They have a controller that sort of aggregates all the network policy information into a way that's going to be easy for the nodes to implement, right? And so that's going on here. You could see it's made a summary of all the K8's data that it needs to consume from the API server.
Yeah,
and
that's what's called the global model.
So imagine the bug reporting situation, right? Like from here, once we move to this, we're going to have the ability people can actually submit a bug where they say, here's the model and here's the node level logs. Here's what my node's doing. Here's what my model's doing. And so what's the problem, right? So,
yes, so there's one thing you can do after that is that you can get out of Vim, of course. And now you can do capping from file.
Okay.
And from file you do. No, it should be from. Sorry, it's a file, not from file.
Yeah.
It's just like a cube, but it's file. Capping space file. Okay, without global state, and you do two API. And now it's using the file as the source for the model. And you can now maybe kubectl exec in another terminal, the bottom terminal, for instance.
What do you want me to do exactly?
Yeah, the same one, because otherwise it won't work.
What am I execing though?
Yeah. So yeah, but that was okay.
Okay.
And now you can run the Coop Proxy node log, for instance. Coop Proxy node log. And yeah, you see it's connecting to the proxy that is serving the file, and you can get your local model from that. And on the KPNG file to API side,
but it's not though. It's connecting to 12090.
Yes, that's expected.
Oh, okay.
Because we didn't set a socket, we set a local port. So.
Oh yeah, you're right. New connection. You're right. Listening on TCP 12090 and connecting to 12090. Gotcha. Okay, cool.
Yeah. Okay.
Yeah.
And
okay,
so
cool.
Yeah, that's pretty nice. And maybe the last thing interesting that the file is actually watching the changes. So if you keep your node log, in the back, in the background.
Yeah.
So Control Z and. Or maybe you can open another Chimux. It would be.
Okay.
Yeah. Okay, and now you can VI the global state.
See, Ricardo, this is why you use tmugs.
Cool.
Okay.
Okay, just do VI global state.
I got it. You want me to mess with it? Okay.
Yeah, and now we are going to, for instance, remove the endpoint.
What if I do this?
Yeah, you can just change the service IP.
Yeah. See, so I changed the service IP, so I got a diff there for that.
Yeah.
Okay, this is cool. So I think this is good. We probably are hit our limit here, and one last thing I wanted to look at was, and this is just for 2 seconds. I just want to do a little shout out. Vlad has been working on a new test framework. And one of the things we're real interested in is building some Coop Proxy test suites, a new set of Coop Proxy test suites that are really comprehensive and easy to read. And so he's got a new test framework over here that is going to be sort of an alternative to Ginkgo that hopefully we're going to start writing some new Kube tests in. So if anybody wants to if anybody's looking for an alternative way to write their tests in Go and they want to play around with this, I think early feedback would be really cool. But it's kind of as you can see, it's very readable, and it's very similar to Ginkgo, but it solves some of the problems that we've seen over time with Ginkgo, like stack traces being tricky to reason about and other things like that. And it's like it's going to have some Kube native features and stuff inside of it, so that not yet, but it will, so that it will be easier to write things that are Kubernetes centric in that test framework. And so I wanted to talk about it a little in the weekend review, but I almost forgot. So I'll put Vlad over here at the top. Vlad's new test framework. And this is being worked on in the upstream as well. It's there's a KEP and stuff like that associated with it. So if anyone wants to try it out, cool. And we're probably going to try to write some Coop Proxy tests in this, or most likely that are more readable. And Doug actually has written an initial prototype of that. Doug Landgraf of some Coop Proxy tests that output a bunch of data and tell you about and are very explicit in terms of what services they're testing, and we're hoping to use that as cross compatibility, backwards compatibility with the old Coop Proxy, so that we can really have a definitive way of moving forward with this stuff. So it's just very early. It's going to take a long time to get there, but we hopefully within a few months, maybe a month or two, we'll actually be able to show IPVS and everything else, all the different versions of NF of this stuff working. Maybe we'll do a second TGIK follow-up on this. So how can I get in the world with being a data scientist? I want to switch to the cloud. Well, why don't you, if you really want to work on some tough problems, we can help you. So as what if you're interested in this stuff, why don't you join Kubernetes Slack and then reach out to like me or Ricardo in SIG Network, and we can help you find a good project to get started on. Ricardo's got a few things. He's doing some stuff with NGINX. He's doing some stuff with, of course, Coop Proxy. We've got some other stuff in the network policy world. There's all sorts of stuff. So we can help you get started.
Sure.
Cool. So thanks, everybody. I'm going to just let everybody go because we're at the 2-hour mark now. But yeah, join us on k8s.io Slack SIG network. Send me a message today I'll help you get started.
Just to answer to Evan, who said you got an endpoint set after the service set. No, it's not that. It's that when we add something, we have the service, then the endpoints, and when we delete something, we have the deletions of the endpoints before the deletion of the service.
I love this button. Next time I'm going to use this button more. I just love this button. I just want to press the button one time before we go. I'm going to give Evan a little. Antonin's here. Hi, Antonin. I didn't even know you were here. Okay, cool. So this was cool. Thanks, everybody. Thanks a lot, Mikhail, for coming and helping me understand the Kaping stuff a little bit better. And Ricardo and everybody else for showing up, especially those of you in Europe and Hunlin, Suresh, Choco, Antonin, the Antria folks showed up. That makes me happy. I've been getting lonely without you here, Antonin. I thought you were going to come drop some knowledge on us, but I just saw you. Thanks, Ivan. See y'all. It's good to see you. TGIK for life.